Hello everyone, my name is Priyanka and this is my Google ADK capstone project called Elderly Care Assistant. The goal of this project is to help caregivers and family members securely access elderly patient information such as medication schedules, healthcare contacts, and patients' health records, while ensuring that sensitive operations are protected through security controls and human in the loop approval workflows. This project demonstrates how Google's Agent Development Kit can be used to build secure, practical, and responsible AI applications for healthcare supports. Before explaining the solutions, let's understand the problem. As people age, they often require assistance managing medications, monitoring health metrics, and maintaining communications with doctors, caregivers, and pharmacies. Caregivers need quick access to this information, but healthcare data is highly sensitive and must be protected from unauthorized access and accidental modifications. The challenge was to build an AI powered assistant that is both helpful and secure. To solve this, I developed the elderly care assistance using a multi agent architecture, MCP tool integration, human in the loop approvals, and a dedicated security checkpoints. Now look at the architecture of the solutions. Every request first enters the security checkpoint. The security checkpoint validates incoming requests, performs input sanitization, detection prompt injection attempts, and enforces security policies before any processing occurs. If the request is safe, it is forwarded to the orchestrated agent. The orchestrated agent acts as the central coordinator of the system. It understands the user's intent and routes the request to the appropriate specialized agent. The health and medication agent handles medication schedules, patient's health information, and health metric operations. The daily routine agent handles routine assistant and caregivers related tasks. These agents interacts with backend functionality through MCP tools for sensitive write operations such as logging patients' health informations. The workflow involves a human in the loop approvals step before execution. This architecture ensures security, modularity, and controlled access to healthcare informations. Now let's see the first demonstration. I will request show medication schedule for patients 1 to 3. As we can see, the request first passes through the security checkpoint and is then routed by the orchestrator to the health and medication agent. The agent invoked the MCP tools called get medication schedule. The assistant successfully retrieves and displays the patient's medication schedules. This demonstrates successful agent routing and MCP tools integrations. Next, let's retrieve patient's contact information. I will enter get contacts for patient P123. The request again passes security validation and routed through the orchestrator. The health and the medication agent invoke the get contacts MCP tools. The assistant successful returns important healthcare contacts, including the primary doctor, caregiver, and pharmacy information. This demonstrates another MCP-enabled workflow and shows how the healthcare information can be retrieved efficiently through specialized agents. Now let's demonstrate the human in the loop approval workflow. I will submit the request. Low blood pressure 120 or 80 for patient 123. Unlike previous requests, this operation modifies patient's information because it is a right operation. The workflow pauses and requests explicit user approval. As shown on the screen, the system generates an approval prompt before proceeding. I approve the request. Once approved, the MCP tool executes the logging operation and returns a successful response. This approval mechanism ensures that sensitive healthcare data cannot be modified automatically without user authorization. To summarize, the elderly care assistant successfully demonstrates all major capstone requirements. The project includes multi-agent architecture, MCP tools, and human in the loop approval workflows, security validation and policy enforcement, healthcare focused AI assistance, automated tested, and infrastructure configuration using Terraform. Future enhancement could include electronic health record integrations, appointment scheduling, medication, reminder, notifications, wearable device integrations, and cloud native deployment. Thank you for watching my Google ADK Capstone project demonstration.